You are my muse. I need you. Not the real you. The idea of you. And by clicking on this video, you've already fallen for my trap. I wanted something simple. I wanted to upload a video of me working out and to track myself. I only got 3% of the way there. But you know, the funny thing about growth is that I complete the other 97% real easily. This 3-second clip is the best I got so far. The funny thing about using other people's code to make your projects is sometimes you just really can't see it that well. I also learned about when you push Docker just a little bit too hard. And right now I'm going to teach you so that way I can learn better. Alright, so we're just going to look at this code right here. It's pretty short and to the point. So we're just going to start at the bottom here. Yeah, it's really short. Yeah, it's not going to really be a problem to understand any of this. Where was it? Right here. Run button, on click, run. Pretty simple. That's it, guys. Thanks for watching. The code I will be using is a movenet example that is hosted on Colab, and I'm going to download it and put it on my personal Jupyter. And so I'm going to make some changes so that it works with my Jupyter. And in the end, I'm also going to add my own example. I imported warnings and set it so that there would be no warnings activated. There are some depreciated things in the image manipulation, and it generates a lot of warnings, especially on the GIF example. And they don't change anything in the final product. I also imported OS and told it I don't have any CUDA devices. The dictionary has names of all the points and the colors for the lines that join them. The left is magenta and the right is cyan, and in between those is a yellow color. The function for key points and edges display makes a few list of points, lines, and colors. And that's all for the drawing. And it also acts as a filter for the confidence level. Draw predict on image has some things about Python I'm still learning. The parameters are crop region and uses that to combine with the image and key points. And what's confusing about this is the fig and AX assignment comes from the PLT subplot. The line segments are added to AX and fig is drawn without needing to draw AX. The toGIF function combines an array of images and puts them into a file called animation.gif. When loading a model, it gives you many options and it shows you how it's handling them. The key points to look out for are the file type and the input size. And it does this thing with a function where it declares it with inside of an if statement, which I don't see in many others except for maybe JavaScript, but I wonder if you could do that in C++. The first one doesn't make sense to me. It seems like you're loading the model with some tensors, and that's not how I do it in TensorFlow.js. The second one makes a lot more sense because you're just downloading it from TF-Hub and then using the model function to load it. The inference on these images is pretty standard. It resizes the images to an input size, for example, 192. The original image is 3000 something by 3000 something. This is then run through the function expand_dims, which allows it to be run through the model as a batch of 1. One thing I've heard of to make it more efficient is running multiple images at the same time. And I've seen this in the training of models, but I haven't seen it in the actual use of models. Once it has run the inference, it takes the key points and draws it over the image of a size of 1280, and it does this because the key points is a number between 0 and 1, and this allows you to normalize the data. The basics of the dance GIF has a loop that does one frame at a time. Some new things are crop region, output frames, new inference method, and a crop region that updates after every inference. The init crop region pads the image so that it is square, and it gives a new object the crop region. And it can be called again later to select the whole image again. The torso visible function only checks for the 4 points if they have a high enough confidence rating. This function calculates the range of the body and the torso. It does this by calculating the center, and then how far the furthest torso is, and then how far the furthest body part is. Determining the crop range is first done by getting the maximum, whether it be the torso distance times 1.9 or the body range times 1.2. This is then compared to the image size, and if it is greater than 1/2 of the image size, it then uses the init crop region to select the whole image. The crop and resize function is made out of the image, the crop region, and the crop size. The crop region, we already know, we've been setting up, that changes into boxes. The crop size is the input size, 192 for example. The new inference method still has a lot of the same thing, expand dims, running the movenet as a function, and it does have something different where the crop region moves a lot, so it adds things to counteract that. And here's the small bits that I changed. I added some libraries I have never heard of, #ChatGPT. I did rotate it because I filmed it vertical, and for some reason it wasn't working very well. It's probably because of bias in the training data, definitely not bad code. And it only is able to parse about 3% of a 100-second video, and that's because it runs out of memory and starts using all of my disk space. I thought of some solutions that I could solve. First, I could chunk it, do it 100 frames at a time, and then save it along the way and combine them at the end. I could also collect a file with all the key points, either a CSV or JSON file with 2,600 entries. And then I could also just do it on a better computer. That'd probably be the simplest, and it'd get it done really quickly. There's also rewriting it in TensorFlow.js. This is more of a exercise in my ability to understand what's actually going on.